Good evening. In the last class, actually, we have learned about inheritance, and yeah, we are going to continue the same concept now. Yeah, we covered the multi-level inheritance, and also we covered hierarchy. Yeah, hierarchy inheritance. Okay, so in this hierarchy inheritance, we do have one parent class, and which contains mul couple of classes, which can be extended, from the parent. So yeah, so in the hierarchical inheritance, more than one class, will be extending the properties of the, uh, you know, um, one class, right? So there is a single parent class has multiple child classes. Yeah. So on high level, if you see this hierarchical inheritance, we can like imagine like a tree structure that it will come, as a collection, right? So yeah, so this is how we like something. Okay, so we write something. Okay, so class A and class B extends A and class C also extends A. So here class A is the parent, and class B and class C are the child classes. So there can be a class B, so also extends a class A and so on. Okay, so this is hierarchical inheritance. Okay, and when you write it in the programming, in the when you can, if you can implement the same thing in the programming, okay, yeah, we need to write separate classes, okay, to execute them. So I have just given them over here. So yeah, my class name is, one second, hierarchy.java. Okay, so what happened actually, this hierarchy.java, so I'm just extending HP parent, and also there is one more H child one, and I'm explaining, extending the same thing, but I cannot execute right now. Okay, so what we need to do, just separate those class files, sorry, this separate those code, from one class to to multiple classes. Then when you execute HL1, you can execute with the parent. Okay, so whatever the parent methods that you're extending from that, you can utilize them, and it can be printed. Okay, so for now I'm just executing this hierarchy. Okay, so it just printed only these things. Okay, this one and this one, address, name. Okay, so just to avoid confusion, so I'm gonna run it one more time. Okay, okay, so yeah, this is of the multi, hierarchical inheritance. Okay, you can implement in the class. Okay, like in the programming level. Okay, so there is one more inheritance type, like multiple inheritance, and Yeah, I will let you know this multiple inheritance when we are in inheritance, sorry, interface concepts that we discuss, going forward. Going forward. So multiple inheritance is also one more thing that, one type of inheritance actually. Yeah. So the concept is, a single child class can, inherit multiple parent class, more than one class of parent, right? So that kind of thing is called as multiple inheritance. Okay. So this can be supported by Java only when we are using interface concept. Okay. So yes, so far we learned about, types of inheritance and how many. Okay, so far we learned about, what type of inheritance we have it, and how a class child class can, extend all the properties from parent. Okay, so we learned about extends keyword, to make sure to inherit those properties, from parent to child, and we just checked about multiple inheritance, but it is not supported by Java until unless we introduce the concept of interface. Okay. Yeah. Next. So we'll go to the next topic, what is called overloading, and so okay. So generally, overloading is a concept like where we have similar kind of names. Okay, and but there should be something different, to call those methods. So when it coming, overloading is generally applied on the methods. Okay, so those methods will be having same names, and the difference that you see in the overloading is the parameters of those methods. Okay, so it might be one, and for the other one it might be two, and the other one it might be three. Okay, so similarly, when it comes to the real-time example, right? Okay, so to address someone individual, okay, we use their first name along with last name, okay, to uniquely identify that individual. Overloading is quite similar. Okay, whenever you call somebody, okay, so you will be calling with their first name, and when we use last name, right? Because if we are having similar people, okay, in the office or anywhere, okay, so with carrying the same name of others, right? So that time what we do, we use the full name, correct? So instead of using first name, we uses something different, right? Adding their last name, and we call them, right? So similarly, if you wanted to call the other person, we instead of calling first name, we'll calling the full name, right? We were just utilizing the uniqueness of those methods, and we are calling, or uniqueness of those names, and we were just calling them accordingly with whenever we required somebody's, right, somebody's presence, right? So similarly, for methods also it is the same. So the method names will be always same, and yeah, the method name will be always same. And the next one, the type of parameters which carries will be different. Okay, so then only the overloading will be a possible thing for a method. Okay, so overloading is when two or more methods in a class have same name but have different parameters. Okay, so the parameters can be different with respect to the number of parameter type. Okay, so Yeah, so this question might be, arised in your mind. Okay, so why I need, the same methods and, with the different parameters can be handled in a single class. Okay, so overloading prevents us like writing multiple methods which perform the same task, right? You know what we will do. Let's say, if you're taking simple example as addition of two numbers. Okay, so addition of two numbers, what you need to write, you're just going to write some method name as add, and you would be passing two variables, okay, to perform those sum and return back the answer, right? So you're passing int a and int b, and you are getting return a plus b, right? Sum of those two numbers. And if you wanted to do sum of three numbers, what you will do? If you wanted to do the sum of four numbers, okay, so generally before overloading, we usually write one more extra method and with a different name and with different parameters. Okay, we implement the sum of three numbers and sum of four numbers. There is one more method with a different name, right? Add one, add two, and then the parameters of those methods will be keep on increasing. But when we have this overloading concept, right? So you don't require to write with different name methods. You don't require to write different names, okay, for all these methods. You can just write one single name, and also with the multiple parameters. Okay, yeah. So you can write with the same name and with multiple parameters, multiple different methods. Okay, this is the same. This is the one which we call it as um, overloading. Okay, so yeah. So if you see this one, there's a class main. Okay, so in that method, I have one method name called don't overload me. And so in the same way, so what we are doing here, the first method is not having any parameter in it, but when we overloaded that, we just overloaded with one string parameter, saying that string laugh, right? Yeah. So so what is going to do, right? When we execute this method, okay, so Java compiler is going to be, responsible to find out the errors, okay? If you are having same name and with the same parameters, then definitely compiler is going to throw an error for you, okay? But so in this case, in the overloading concept, like, if you are having multiple parameters, so Java compiler can identify this as like, it has multiple. Okay, so multiple parameters, there is a difference between these two methods. Okay, so similarly, then it is not going to throw an error and you'll be able to execute the program. Okay, so how the method call will happen depending on your parameter, it will be able to identify the respective method, and it will be executing the output for you. Okay, so if you see here, um, there are two methods, right? As I mentioned. Okay. So one is like without parameter and one is with parameter of string laugh. Okay. So we executed this program. Okay. Don't overload me. And I passed a string over here. So what happens, right? So output is going to be like whatever that the string that we passed it here, right? So you can see that the string has been printed in the screen. Okay. So let's go to the next one. Okay. Yeah, this, so overloading is like, just to recap, it will be having the same name of method in a class, okay, but different type of parameters, okay. So either one, two, three, whatever. And in the similar terms, actually, we have one more concept, overriding. Okay, so overriding is like, a little bit different, when we compare with the overloading. Okay, so overriding comes, comes into the picture when we have inheritance in place. Okay, so there is a class A and there is a class B, which extends class A. Okay, so whatever the properties that, or anything which is related to class A are going to be extended into class B. Okay, so now what happens actually, in class A, okay, and class B, both are having, similar kind of properties, and so it externally, generally class B is having all the properties of class A, correct? So what happens, like, in the class B, there is a unique property that has to be there, but it is already present in the parent class. Okay, so you have to override that. Like, you don't want the class A's property should be coming into your class B. So for that case, we have a concept called overriding. So we're going to see that, just, for one more time, one more example. So if we have a color property which is exists in the class A, and class B wants to hold a different color. Okay. So so the method that we are going to write some, okay. So the method that we are going to have it in the class B for printing those color, or for something, whatever, right? So we are going to write it again, with the same name and with same parameters, whatever we have it in class A, okay. And we are going to implement whatever the color that you wanted to do in B, in class B. So when you say what is overriding, overriding is a concept called whenever we have uh, whenever we have a mul at least in a single inheritance, which is having a class A, and it is having some method A, and we are having class B which extends class A, and also having method A with a different logic inside it. Okay, so that means you don't require to have multiple parameters or something. It should be the same parameters that what we have it in the class A. Okay, so you got it right. So in the class A and class B, okay, so the method should be there, and the method should be having same parameters and same name, okay, but different implementation inside the logic. Okay, right. So some of the members, okay, when we go to some, basic example, we usually have a family members, having a nickname, okay, as their real name is very long, hard to call, right? So in that case, nickname is being used to identify the same individual, right? So overriding is also aligns perfectly with the above example. Like what we does, we are going to utilize their nicknames, to call them, right? But here, actually, what the concept is little different. Okay, so when we require a separate implementation or anything else, we usually use the overriding for that particular class. Okay, so overriding is when two or more methods in separate classes having a child parent relationship have the same name, okay, and also the same parameters, but the two methods are not written in the same class. Yeah, the method which overrides the previous one is written in a child class. Okay, so this enables us to provide specifications while implementing the same function in a child class. Okay, so let's let's see how it goes. Okay. So if you see here, this is a parent class and this is a child class. Okay. So I just extended that parent class and we already have a method, old method, right? So if you see here, we were using the same public void old method. And if you see system.out.println, the logic inside of it is little different when you compare with others, right? With the class A. Okay, so the out statement is little different. Okay, so here child class is a hierarchical, class inherited from parent, which contains the same function, old function declared in a parent class. Okay. Yeah, let's go to the next topic. Okay. So the output is okay. So when we create a parent class object one, but you are passing a child class reference to it, right? Sorry, create a reference of parent class and you are passing child class object to it. So when you call object one dot method, it will be giving you the the this one, okay, the child class answer, right? The implementation. Okay, just a minute. Okay, to summarize whatever we learned it now, okay, so it is called overloading and overriding. These are the two concepts that we learned it today. And overloading is when, to recap actually, when two or more methods having the same name but different parameters within a class, okay, we call it as overloading. Okay, so what is overriding? Overriding is, when two or more methods having the same name and carrying with the same parameters, but written in extended classes, okay, separately, the parent and child class, right? So which we call it as overriding. Okay, so when we have this concept learned, so the next, object oriented feature is polymorphism. So what exactly the polymorphism, right? you know a real time, okay, real life example, polymorphism can be the moon viewed from the earth. Okay, because there are many forms that you see, okay, that you see, moon from the earth, right? it always it always have different shapes. Okay, so we call it as phases of moon. But in the object oriented programming, polymorphism is a way to perform a single action in different ways. Okay, so what exactly this, right? Polymorphism. So it just now we learned about overloading and overriding concepts. Okay, so that will be useful in the polymorphism. Okay, so let's see how. Right, in Java, polymorphism can be viewed as the capability of methods to do different things based on the object that is acting upon. Okay, so we have almost did the same thing, in our previous concepts, right? In the overloading and overriding concepts, right? So let's go and check. Okay, so method overloading falls into polymorphism. Okay, as it allows us to define a thing and use it in different numbers. Okay, so but wait. So what if method overloading is a type of polymorphism and method overriding is also, uh, a type of polymorphism? Okay, so we already know what exactly method overloading and method overriding is, right? Okay, so let's check on method overloading. Yeah. So if you see here, like, polymorphism contains, two type of polymorphism. One is static and the other one is dynamic. So when you say static polymorphism, what it is, static polymorphism is nothing but method overloading. Okay. One second. Yeah. Yeah. Static polymorphism is also known as a compile time polymorphism, and it can be achieved only through method overloading. So when you say static polymorphism, it is like the same thing, whatever we learned on method overloading. It is the same pattern it follows with the same name and with a different number in the single class, right? We call it as polymorphism, right? Sorry, method overloading. Okay. So if you see the example that we use it here, okay, so don't overload me. That method, is overloaded with a string. Sorry, with a string. Okay, so the second one is dynamic polymorphism. The dynamic polymorphism, when we go here, right? So why we say it as dynamic polymorphism, right? So the when we are, when we are inheriting a class, and if you are trying to maintain the same method with the same name, right, and with the same parameters, so our runtime, Java runtime, will be having a problem to execute these things, right? Because it might be in ambiguity when you are calling those methods, right? So what we need to do here, right? So whenever you are trying to utilize dynamic polymorphism, so the object creation of those classes is like, plays very, you know, very, very good role, okay, to create those references, based upon their address, right? So if you want to execute something in the child class, so the child class object has to be created, and it has to run, sorry, it has to call the overloaded method first. Sorry, overridden method. Okay, so it's old method that you are going to call it. Okay, so one second. Okay, so in Java, right, polymorphism is like, it's an unavoidable in Java because we are going to utilize in so many places, okay, when we are into an application development or, anything, right? So overloading and overriding, extending classes, okay, all contribute to polymorphism at the end, okay? So we just saw what exactly those polymorphism concept, and we have a lot of other things that we learned, about polymorphism and other things, okay, overriding, overloading, and the inheritance concepts, right? So yeah, to actually to summarize, right, what exactly polymorphism. So it has many forms, okay, it's a way to perform a single action in different ways, so that we call it as polymorphism, and it is internally having static and dynamic polymorphisms, okay. Dynamic polymorphism or runtime polymorphism achieved through method overriding, and the compile time polymorphism, it is achieved through method overloading. Okay, so let's go for the next topic, which is abstraction. Okay, uh, when you have abstraction, okay, so you just remember about the car, okay, and in the car, when you sit in and when you're driving, you're just going to see what are all the things that are useful to move your car ahead, right? So like, accelerator, clutch, and the brake and the steering, all these things, the controls that are useful for you, to start your car and, to move on. Yeah, those controls, whatever you're seeing, it's are very limited. Okay. So inside of those controls, there is a big process that it is going to run for some time, right? So that that's what we call it as abstraction. So whatever the necessary things that you wanted to see, yeah, you can see them. But the other things, no, you cannot. Okay. So that concept we call it as abstraction. So when it come to the, Yeah. So when it comes to the, the car, right? That is the example that we are checking on it. So yeah. So what exactly that we are going to focus? We're just going to focus only on whatever important while driving, right? So those things are exposure to the user, and they're utilizing them, depending on those input, right? So and once it is done, okay, so it is going to it is going to perform, like if you're clicking on a button, or if you're going to perform something, so internally it is going to handle those, okay. But the concept that we have it, okay, so hiding unused or unwanted things and giving you the one which you can directly use it. So this concept we call it as abstraction. Okay, so abstraction is a process of hiding the implementation details from the user and providing only the functionality. Okay, so in other words, abstraction is a process of hiding background details and focusing on the essential details. Okay, so this way that user will be knowing user will know the answer to what, and how of it. Okay, so this can also be viewed as a data hiding or only showing the essential details. This becomes unnecessary, as not every user has to see or know everything. Okay, so for example, a person who is using a software does not need to view the admin panel. That's of no use of that's of no use him, right? Basically. So also the security is at risk if there is no abstraction, right? So in general way, that whatever you needed, you just expose that to the client. Whatever you don't need, you can just hide them, without their notice. Okay. Okay. So how we implement abstraction, right? So in Java, abstraction can be achieved using two things. One is interfaces and the other one is abstract classes. Okay. So when you say an abstract class, so abstract class is a incomplete class that we can say, to use it, we need to extend it. So when you say abstract class, what exactly it does, right? So in when you create an abstract class, okay, you might be using a couple of new use keywords, okay, to perform those abstraction concept, right? So abstract is one of the keyword, to declare the class as abstract, right? So when you declare it as abstract, right, for a class, what exactly it does? An abstract class may or may not contain abstract methods. Okay. So but an abstract method is a method without a body. Okay. So it is only declared in an abstract class and defined in the class which extends the abstract class. Okay. Okay. So when you have at least one abstract method in your class, so it is recommended to, write, um, it is recommended to have that class, prefixed with abstract keyword. Okay. Yeah, this is how we write it. Public abstract class name. And inside that, you are going to write some method. Okay. Which is not having any of the implementation. Okay. So there are no differences while writing a class and an abstract class, just only the keyword is the different which we use, for abstract, right? So, and there is one more class that we are extending. the child, class name, right? And that means like, whenever you wanted to implement those abstract method, you can implement it in here. Okay, so I'm just going to this. An abstract method is a method which only has a declaration of the method, right? So you are just writing this thing, public abstract, some return type and the method name. Okay. Okay, to summarize what exactly the abstraction is. Abstraction is the process of hiding background details, and focusing only on the essential details. Okay, so in Java, abstraction can be achieved using interfaces and also abstract classes. Okay, so while writing an abstract class, okay, or an abstract method, okay, so keyword abstract is used for them. Okay, so an abstraction method is a method without a body, and it is only declared in an abstract class and implemented in the extended classes. Okay. Okay, so the next one is encapsulation, right? So if you see the image, whatever you're seeing it over here, so there is a bottle, okay, so which is having two marbles inside it, okay, and which is having full water in that jar. Okay, so if you wanted to remove those two marbles which are sitting at the bottom of the jar, right? So you wanted to remove them, but if you put your hand, actually, it is going to be spill out all the water, but we don't want it to spill out all the water. We just need those marbles to be outside of those the jar, right? So how we do that? Correct. So if you have some two tongs, okay, to get those marbles out from the jar, you can still do that tong, and you can utilize to bring it back those marbles. So similarly, when you apply the same concept in Java, you see a plain Java object, Pojo, right? Or a sing class, which is having all the bean related information, right? So those things are, let us consider a class, A, which is you wanted to utilize it as a bean. Okay, so when you wanted to utilize it as a bean, if you declared private variables in that class, so how do you gonna use them, okay, in your class, right? So we are going to utilize them in a way where we are going to utilize, or we're going to retrieve those private variables, or whatever we have it for under this. Okay, so we are going to call, we are going to call those private variables either using a setter method or either using a getter method from the classes, right? So so this setter and getter method from the bean concept, right? It is going to accept, okay, it is going to accept as a you know sorry, yeah, so encapsulation is a concept, right? To 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 call, to get those private variables which are declared in the class. Okay, if you wanted to access them, so we need an implementation of the getter setters methods for that variable. So you need a tong to retrieve those private variables inside the class, right? So what are all those tongs? We call it as, in real-time Java program, we call it as getters and setters. Okay, So we utilize getters and setters method, only to retrieve and only to display on the screen, right? So this is called, the encapsulation. So encapsulation is a concept in object oriented programming, and which describes the idea of bundling variables and methods together. That's what we have done, right? So we are going to combine getters and setters with the variables. So this is what we does, right? There's a variable. We were just utilizing a tongue, to connect those methods and variables. Okay, so the variables are declared as private, and the methods to access them as public, so that they can be accessed from outside of the classes. Okay, so then only these methods can be used to set or get the values of the variables. Okay, so encapsulation provides a protected space for data members and and restricts the access outside of the class. Just only the yeah. So what exactly it is going to print, right? It is going to print, or it is going to provide the access only to those getters and setters instead of direct a private variable from from a bean class, right? Yeah. So if you see an example over here, so there is a class student, which I was just utilizing it here. There's a private string name, and there's a private int roll number. Okay. So what we've done, we just added set a method. Okay, set name and set roll number, which is having those string as own name and integer, okay, as a roll number. Okay, so we were just assigning the values whatever we got it from outside. We're just assigning it to the bean. Okay, so the same way, name is equals to new name and not underscore roll number underscore number is equals to full. So this is how we are going to utilize those setter methods to set the values of a private member, right? And how do you retrieve them, right? So yeah, so as I mentioned, right, set roll number and set name are declared as public, so that you can utilize these two methods whenever you wanted to go ahead and check on the yeah. So whenever you call the set name or set roll number, it is going to perform the add of the value whichever you are you're creating it here. It will be moved to there. Okay, so that's how we utilize the private members using the setters and getter methods. Okay, so you have just written only the set, right? If you wanted to get the values. Okay, so yeah, it's the same thing that we discussed. Okay, so we're just bundling those the private members with the private methods, sorry, public methods. Okay, setter in the set and get values. Okay, so still now we were just utilizing the values. Okay, whatever we have it of in a student name. So you are having a private member string name, and you're just passing those name object one dot set name is rocket, and the object one dot display name. So display name is nothing but just print what exactly we have it under name, right? So whatever you are passing it from here, rocket, you're just passing it to the subject OBG1 subject, and object one dot set name. So set name, it is directly going to be here, and it is setting the value to the variable, and it comes back. Okay, so it so when you call the display name, it is going to just display the name that you passed just before. Yeah. So just to summarize, encapsulation is a concept in object-oriented programming, which describes the idea of bundling variables and methods together. So the variables are declared as private, and the methods to access that private variable, okay, are declared as public. Okay, so as they can be accessed from outside of the class. That's why we have public over there. Okay, so encapsulation provides a protected space, for data members and restrict the access for outside of the classes only by, going into something. Okay, so the next one is what exactly an interface, right? So, so what is this encapsulation, right? So sorry, inheritance. So inheritance is the same, sorry, not inheritance, interface. Okay. So if you guys remember, like when we are discussing inheritance, okay, so we need a couple of classes which can be extended into single class. In this time, we don't have, uh, we cannot extend multiple classes into one, right? Okay, so the extends keyword is not going to, you know, help us, when we are using, the classes to extend, right? Interface, what is an interface, right? Interface is, um, you know, provides a complete abstraction of the, you know, instead, just now we learned about abstract classes, right? So what interface does, more than that. So it won't be having any single method inside the class, but it just only the, you know, it contains only the declarations of the classes. Okay. So if you wanted to implement those methods, you have to implement your current version of, you have to implement that. And, when we when we call those methods, okay, in some other class or something, instead of getting those interface things, we are going to keep on get executed with those first name and last name, whatever we have added it into the class, right? So consider we have a write classes, for cars, okay, so which displays their individual features, okay. So we will require different classes for different cars. Okay. So now, but the futures may be different, but the methods that we are going to write it under these classes will be always same. Okay. If you wanted to show some features about your dashboard. Okay. So you're going to write a dashboard method. Okay. To get all the dashboard related information from from the class, or you are going to get, depending on the functionality. Okay, so let's consider one small example here. We, as we mentioned, we required some different features and different class, for the different cars, right? So but all these are a lot of features which are same across the cars. Okay, so all these similar features are moved to, an interface. Okay, so which is having only the declarations but not the implementation of those methods. And when you move that place, you can still utilize that, or you can just call the other class, to implement those methods. Okay, so whatever it is declared in a interface. Okay, so the class and interface is like, it's like looks very similar, but it just, class is declared as a class, and interface is declared as interface. Okay, so interface acts as a reference for the other classes, and inheritance is a collection of abstract methods and constants. So whenever you write something, if you want to call something in the uh, in an interface, right? So what we do, it's the same way what we have earlier, method Java, and we just write the same code, okay, to pull the data from that class, right? So when you are creating an object of that implemented class for interface, we generally use a reference of the interface, to for the for the class wherever we are using it. Okay, so the implementation class, and when you create that object, okay, so and pass it to that reference of the interface, then the data hiding is also works over there, and you can just directly utilize those values. Okay, whatever we are getting it, sorry, whatever we implemented in the child class, you can directly get them when you execute the program. Okay, so I'm going to show you these things in the next class. Okay, so where exactly these interfaces are used and how we can achieve some of the concepts that we are not able to do it in the inheritances, right? I'm gonna show you those examples in the next class. Okay, so yeah, so an interface is written like exactly like a class. Okay, if you see here, public interface and interface name, and you write inside these braces, we write those members. As interface, itself is an abstract, so you don't require to use any abstract keyword. Okay, so the methods which are declared inside the interface don't need a keyword called abstract, because interface itself an abstract class. Okay, so abstract one, so it doesn't require anything specifically to declare it as abstract. Okay, so if you just check on the screen, the public interface student, so which is having display name and display rule number, these are the two methods we have it under interface. Okay, so when you implement that, okay, in the class, that's it. So if you have implementation of that child class, sorry, yeah, implementation of the class, so that's it. It is like yeah, so okay, so when you have the implementation of that class, right, sorry, interface, so you're going to override these two methods inside that class, and this can be used, okay, as a different forms. Okay, so one is one is abstraction, and that will be completely achieved when you extended this interface to a separate class. There you can write it whatever you wanted. Okay, so how to use an interface, right? Just uh, use the implement keyword and implement that into your class. Okay, so we already declared a couple of interfaces, and we just saw that how to implements. Okay, so an interface, so the class name using implements keyword, you can just implement the interface name over there. That's it. So yeah, here is the concept. So if you have this implemented student, so you are going to override the display name and display roll number, and you're just printing them. Okay, so the main keywords that we used is implements, okay, instead of extend, because this is an interface. Okay, so to do so, we use our very own keyword called extends, but the extends is not going to work. Okay, so only for for implementing an interface to a class, it's only used implements. Okay, so if you wanted to extend an interface to interface, right, then you utilize the extend keyword to get that interface into another interface. That's it, right? So if you want to extend the student interface, okay, that we need to declare, we'll write one more extra number, new student, and which is extending the student interface, and which is also having some admission number. Okay, so if you want to implement multiple interfaces, okay, into one class, you can just separate it with the comma, and you can just write it, those names. Okay, so an interface is a collection of abstract methods and constants, and interfaces are used to achieve the complete abstraction and the multiple inheritance. Okay, so an interface is abstract. There is no need of declaration separately saying that this is subtract, right? So a class can implement another interface, okay, but like a class can extend other classes. Interface is also capable enough to extend those. Yeah, um, yeah, extend those interfaces into the other. Okay, so yeah, so we'll cover the next topic, exception related things, in our next class. Okay, so if you guys have any questions or something, let me know. Otherwise, feel free to drop off.